Hey guys, this is Srini and you're watching Python tutorial videos on my channel Python for Microscopists on YouTube. This tutorial is an extension of the previous tutorial where we talked about watershed based segmentation of grains in a microscope image. Now, this is an extension because in the previous tutorial we did that for one image. Now, what if you want to apply that to multiple images? Yeah, there are various ways of doing this, and it depends on whether computing time is important to you. It depends on whether ease of use is important to you. It depends on whether you want to write it in a very easy way. That's what I tend to do it now, because the automation time, for the computer to do this, I so far am okay with it. Unless you get into deep learning, where every second is important because you have thousands or millions of images that you're processing and every second adds up. That's a different scenario. Right now, I'm going to show you two ways of doing this, applying whatever you have written, the code, to multiple images. One is putting everything into a for loop. The other one is just defining your, image processing pipeline as or image processing task as a function. And both of these approaches we talked in our earlier tutorial, so this should be a pretty quick one. Now, I've opened up a file that I have created while going through, in one of my early, really, probably fourth or fifth tutorial. It's called Reading Images into Python. And the last thing we did as part of that exercise was to read the images, but then read multiple images. And for that, we used glob library. And glob, again, came from this Unix operating system back in the day. And what glob actually does is it actually goes through the entire path of a directory or a folder structure and retrieves the file names of all the files. So we're going to use this to actually retrieve the file, define what the active file is, and then perform a task. So I'm literally going to copy these lines, okay? And we may as well copy these other lines and then edit this code that we have developed as part of the previous tutorial. So without comments, this looks very ugly, but then it's a pretty short program here. Again, always comment your code, okay? So we started off by pixels to micron, reading the images and thresholding them and doing some morphological operations, then segmenting, clearing the border, meaning removing the edge touching grains. And then we have identified the definite pixels that definitely belong to background and performed a distance transform to use it to identify the pixels that definitely belong to foreground. And we created a mask out of this or a markers out of this. And those markers went into the watershed algorithm as the mask, and it just found the boundary. And we just we took that and extracted a whole bunch of region properties where we printed out area, equivalent diameter, and all of this into a file. Now let's apply this to multiple files. Okay, so first thing first, let's paste what we have copied from the previous tutorial. Okay, so my path is, I created a path called grains, and let's just do this. Let's double confirm it. So all I did is I actually have one grains picture. I cropped this, which we used in our previous tutorial, and I cropped it in a different way. The whole point of showing doing this is the original image here is 640 by 443. This one is 410 by 354, and this other one is 297 by 434. So it doesn't matter what format, what the aspect ratios, all your images do not need to be the same size, at least based on the method I'm talking about right now, okay? Using the process I'm talking here. Anyway, these are in images and grains, and that's where we are, images and grains. And we forgot to import glob. Okay, so there you go. So we've imported glob, and by the way, let's keep the pixels to microns out of the for loop, because I'm going to create a for loop in a minute. Let's keep this out of there. I mean, there is for loop right there, right? So all of our code should go into this for loop now. So our path is images slash grains slash, whatever file. In fact, since all of our files are JPEG, let's just say only look at JPEG files. This way, if you have any other files in your folder, it's going to skip them. Otherwise, you'll get some weird OpenCV error, and you'll never figure out exactly what the issue is, because OpenCV errors are very cryptic. So I deleted those. Now everything in the for loop obviously should be indented. So I want my image1 and image, but my image1 is not cv2.imread, right? So my image1 is, I'm just thinking, why did I actually delete that? My image1 equals to cv2.imread, except this is imread file, right? For file in this path, it's going to retrieve the first file, and that's image1. Okay, the second line I don't have to change because it takes that image1, and converts that to gray level. So it's very easy actually to automate this to multiple images. So from this point on, I am going to just indent everything to make sure it is part of my for loop. That's it. I should be all set. It's that simple. Okay, sure, foreground unknown, this, I'm just hitting tab. As you can see, markers, image1, this, regions equals region props. Okay, that's also part of this. I don't want this to be as part of the for loop because this is something we are defining once. What is my prop list? My prop list is area, equivalent diameter, and all of this. So I'm going to cut this out of here and paste it outside of my for loop. Okay, so back up here. So anything that I do not really want to be part of for loop, I'm just taking them and then throwing them out of the for loop. That's pretty much it. And for loop is there only so we can iterate through all of our images. And I don't want those bunch of lines to be iterated while we're doing this. Okay, so where are we? I got distracted. Output file is, and by the way, these two also, we are writing it once, so we can throw them up here. Okay. Again, just to remind you, what this is doing is it's opening a file called imagemeasurements.csv. In fact, let's open it under images slash grains. So we separate this in the same folder as our images, okay, or input images. So it opens that, and then it outputs a file, and the first column for the first line, it's actually going to, first row, it's going to print out all of these. So these need not be as part of the for loop. You'll find out if they need to be, but I think we're okay now. So grain number, this is where we need to be a bit careful. We have a for loop here that needs to go there, that needs to go there, that needs to be indented. Oh no, too much indentation there. And this needs to be too much indentation again. All I'm doing is I'm indenting the code to make sure it is part of this for loop. That's pretty much it. And output file dot write, and that seems to be, no, that should line up with else. And creating a new line that should line up with this for, right? That should line up with this for, and I hope it is lining up. It's tough to see right now, and my grain should line up with the output. Okay, and I added a line output file dot close because in the previous tutorial you may have realized when I opened an Excel file it was saying read only. That was because I opened the file but I never closed it. So this one actually closes that. I think this is pretty much it. Let's go ahead and run it. That's it, right? Okay, we'll find out when we run it. So go ahead and run this, and it's done. That, am I not showing any images? Okay, it looks like we're not displaying any images, which is okay. So it seems to be done. And in fact, if we show some images, we would have seen a few images pop up. But let's see what we have here. So as you can see, it created a CSV file. And let's go ahead and open it. Okay, again, this is opening in Excel, which takes its time. And let me drag it over here. There you go. So grain number 1, 2, 3, 4, 5, 6, area, and and then the grain number should probably repeat. I don't know, in the first image it should have found like 500 some grains. There you go, 430 grains over there. And then the second image started in the third image. If you want to add an image, actually we should have done that. If you want to add, let's add one line to this, okay? So string before this, I would like to do output file dot write, okay? Let's write the image name. So that would be file, I mean the file name, sorry. That would be file. And then we need to separate this, right? Every time you add something, you need to add a comma because we are trying to create a comma separated file. So we did this, and let's see if this makes sense. Okay, output file, write file, and grain number. And I'm actually thinking whether we should add a file name up here. Okay, we copied this grain number and everything. Okay, let's do that. Why not? Before this, I'm thinking because I don't want to break it by thinking about too many commas and all that, but that's okay. Let's be adventurous. Okay, so well, this is file name. I get distracted too easily. And after file name, we need to put, don't forget to put this comma. And are we good? Double quotes. I mean, it doesn't hurt, but okay, so file name is fine, the first column, and then separation, and then grain number, and then a blank one. Okay, let's run this. Takes exactly 3 given, right? Takes exactly 1 argument, 3 given. What did we do? In which line? Line 1. What does that mean? Output file dot write. Did we give 3 arguments somewhere? Line 22. Okay, so 22 file name. Okay, we may have done some mistake here. Okay, so file name. Oh, sorry. This should be plus. Not. It's not multiple arguments. This is actually file name. Add comma to it, and then add grain number to it, and then add comma to it. Okay, you probably got it. I missed that point there. Okay, so run it. There you go. Let's open this one more time. And now we should have a column with the file name, so you know exactly which what values correspond to what grain. So there you go. Let me expand this. It's taking grains 1 as the first image, and then these are the numbers within that image. And then let me scroll down, and we should see after 4 some hundred something, we should see, oh, grain 2 starting over here after 430. That's where the grains 2 started, and then the number started again, the numbering. You can always run the numbers all the way through if you want, but I'm just separating them here. Okay, and then grain 3, and then so many numbers up here. So this is one way of doing it, and the other way, I actually have already written the whole thing, and let's see, and let me open a new file. Actually, I have something called temp. Let's go ahead and open this temp file, and let me open. There you go. So the way I'm doing it here is, again, I could have showed you, live, but it would be boring. So I took exactly the same approach, except in this case, I defined a function called grain segmentation, which takes an image as input. Once the image goes through, okay, what we did here is, let me go back to the previous file. So once the image is defined, what happens? The first step is thresholding it. That's exactly what this is doing, thresholding. And then kernel opening, exactly the same thing, kernel opening, all of this, all the way up to the regions. I commented this, but all the way up to regions, everything is part of my function. And what does the function return? It returns regions. Okay, and this is all the main program. This is outside of the code. Okay, well, outside of the function, sorry. So outside of the function, I define pixels to microns and my property list, my output file that I wanted to output, image measurements 2.csv this time. And this is exactly the same, file name plus comma plus grain number, no difference, right? Except here I have defined it up here. Here I defined it down in the main program, pretty much the same thing. And then import glob, the path file name, print file, CV2, converting this image into this. And this is, and at this point, I'm calling the grain segmentation function, okay? So all of that meat of our code, I packed it into a function called grain segmentation. And now I'm unpacking that right here by supplying this image as my input parameter into this. That's it. What does this return? The regions. It actually, obviously it's returning the regions, and then I'm taking that regions, okay? And for region props, this part is same as this part down here, okay? This part, that's pretty much it. There you go. And let's go ahead and run this. And it's, you see, it's printing grains 1, grains 2, grains 3, because we are printing apparently print file right there. Okay, it's printing which file. So I know it went through grains 1, 2, and 3. And now we should see a new file called image measurements 2.csv as part of this folder right there, image measurements 2. And it should be identical to the other one. There you go. Okay, so grains 1, and you should have about 400 some. Oh, it's showing 577. Probably one of the, we can go back and see why. But again, this is grains 1, grains 2, and then we have grains 3 down here. Now, the reason why we may have 500 or something is probably part of this. I changed it. You see here, cv2.dilate. I'm using 2 iterations. Here, I think we used 1 iteration or something. Yeah, iterations 1. Okay, so experiment with these and then see what parameter, how many iterations and what type of morphological operations will give you the best result. But this is how you apply this to multiple images. Okay. There are, again, many other ways of doing this. If you have a TIFF stack, you can unpack the TIFF stack, and there are a million ways of doing this. These are the easiest ones based on the knowledge that we have gained until now. Okay, so if you like this tutorial, again, please go ahead and like this video. If you like the videos that you find as part of this channel, please subscribe, which keeps me motivated to create more such videos. And in the next tutorial, frankly, I haven't planned what I'm going to do next. So let's cover a different topic in our next tutorial, and I'll see you then. And until then, enjoy life, have fun. See you in our next tutorial.